of DeepSWE Pros. Yet solutions require 5.5 times more code and 2 times more output tokens. Now, this is super important because if you're like me, you're not giving your model, your coding model, extensive prompts explaining exactly where to find something, what the problem is, tests that you've already run against it, failure cases you know about. If you're anything like me, you're typing fix it, and that's it. So not only are the prompts much shorter than DeepSWE, the solutions require more code and more output tokens. And that's really important. So it's a much better test of what the model is actually doing. It is a much better test of if the model is writing good code or not how well you can explain the problem to the model. And then next, reliable verification. This was stunning. They were able to reduce the false positives and the false negatives substantially, and I'll show you that later in the video. They specifically call out DeepSWE Pro, which is kind of the gold standard of benchmarks for coding right now. Existing benchmarks fall short. DeepSWE Pro, the leading agentic coding benchmark, has tasks averaging just 120 lines of code to solve, and our audit found its verifier misgrades agent outputs at rates of 8% false positives and 24% false negatives, which means the verifier, to verify whether the solution presented by the model is right, it thought it got it right and it was actually wrong, or it got it wrong and thought it was right. And obviously that's quite bad. Okay, but here's what matters. This is the actual leaderboard. And as you can see, GPT 5.5 extra high is absolutely dominating. Okay, this is different from everything else that we've seen. All the other benchmarks which show Opus 4.7 and GPT 5.5 effectively around the same score. Here, we are seeing a 15+ point difference.